Very good morning, students. Today I'm going to tell the remaining part of the Unit 3. To tell my introduction, my name is A.S. Gosia Banu, uh, Associate Professor of Narasimha Reddy College, and the remaining part of the third unit I'm going to cover today. Okay, the next, what I want to tell is, you all have to practice the practical section, and then only you can understand this better. So let's go into the topic, the functional dependencies. So what is functional dependency? Is a relationship that exists with one attribute uniquely determines another attribute. So dependency means we have to depend on another. What we have to depend on another attribute. So functional dependency is a form of integrity constraint. As we have read, what is integrity? We have heard what is integrity constraint and can identify schema which redundant storage problems and suggest refinement. For functional dependency, A is depending on B is a relation holds true if two tuples having the same value of A also have the same value of B. For example, tuple of 1 of x is equal to tuple of 2 of x. So then T1 of y is equal to T2 of y. Where T1 and T2 are tuples and xy are attributes. Reasoning about functional dependency depends upon the Armstrong axioms. Defines a set of rules for reasoning about functional dependency and also to interfere all the functional dependency on the relational database. The various axioms are reflexivity, argumentation, transitivity, and secondary and derived axioms are union, decomposition, and pseudo-transitivity. We have discussed in the previous classes. Attribute closure of the attribute set can be defined as a set of attributes which is functionally determined from it. To find attribute closure of the attribute set, add elements of attribute set to the result set. Recursively, add elements to the result set which can be functionally determined from the elements of the result set. Types of functional dependency are trivial functional dependency, non-trivial functional dependency, completely non-trivial functional dependency. Let's see into this. If x is depending on y, and if the functional dependency of y is a subset of x, this type of functional dependency called trivial functional dependency. Now coming to the non-trivial functional dependency. If x is depending on y, next y is not a subset of x, then that is called a non-trivial functional dependency. Here, the third one is completely non-trivial functional dependency. If x is depending on y and x's intersection of y is equal to empty, that is null, then it is called completely non-trivial functional dependency. Prime and non-privative attributes. Attributes which are parts of any candidate key of relative is called the prime attribute. Others are non-prime attributes. We have seen this one also in the previous class. But for the continuation sake, I have to tell this. So candidate key is a minimum set of attribute of relation which is used to identify the tuple uniquely. Consider student table where student has the attributes S number, S name, S phone, and age, where S number is the candidate key. We have more than one candidate key in the table of candidate keys. Simple having only one attribute. Composite means having multiple attributes as candidate key. Super key is a set of attributes of a relation which is used to identify the tuple uniquely. Adding 0 or more attributes to candidate key generates a super key. A candidate key is a super key and vice versa is not true. Consider student table where student is a table and S number, S name and S phone and age which is there in the brackets are other attributes. We can take S number as one set and S number, S name as super key. Next, coming to normalization, as we have seen anomalies, We have seen functional dependency. We have seen what is constants. Next, coming to normalization, is a process designing the consistent database with minimum redundancy, with support data integrity by creating or decomposing given relation into smaller relation, preserving constraints on the relation. So normalization removes data redundancy and it helps to designing a good database which involves a set of normal forms. First normal form, second normal form, third BCNF, Boyne's code normal form, and fourth normal form, fifth normal form, sixth normal form, and domain key normal form. So first normal form, what no repeated data groups are there. Second normal form, no partial dependency and no repeated data groups. Third normal form special feature is no transitive dependency, no repeated data groups, no partial group dependency. Boyne's code normal form is no repeated data groups, no partial keys, no transitive and reduced key dependency. Fourth normal form is no multiple value, reduced key dependency, no transitive dependency, no partial key dependency, no repeated data dependency. Fifth is no joint dependency, that is no multi-value dependency, reduced key dependency, no transitive dependency, no partial key dependency, no repeated data groups. Okay, so here this is what is there. That means the second is having a feature of 1 plus no partial key dependency. So coming to the fifth normal form, all the 4 features exist and no joint dependency. So that is nothing but the reverse subset. So property of 3NF, BCF and 4NF we have seen in the previous classes. Next, coming to the lecture 10. So first normal form, as relation is said to be the first normal form if it contains all atomic values or single value. Rules for first normal form. The first normal form accepts you to follow a few simple rules while designing a database, and they are rule 1, single valued attributes. Each column of the table should be single valued, which means they should not contain multiple values. We will explain this with the help of an example. Let's see the other rules for now. Second rule, number 2, attribute domain should not change. There is more than one common sense rule. In each column, the value stored must be the same kind and type. For example, if you have a column date of birth to save date of birth and set of people, you cannot and you must not save names and some of them in that column along with the date of birth. That means date of birth means we have to write only DDMMYY or MMDDYY or YYDDMM in that format, but not storing the names. That is not that. That is the common sense we all should have. And others in that column, we should hold only date of birth for all the records and rows. UNI3, unique name for attributes and columns. These rules expect that each column in the table should have a unique name. This is to avoid confusion at the time of retrieving data and performing any other operations on the stored data. If one or more columns have the same name, then the database management system will be left confused. Next rule number 4, order doesn't matter. This rule says that the order in which you store the data in your table doesn't matter. So coming to your domain is there and courses are there. Programming, the courses are C and Java, web designing, HTML, PHP. The above table consists of multiple values and single column which is reduced for atomic values for using first normal form. Domain and courses are there. Programming means C, Java, web means HTML and PHP. So second normal form. In the second normal form, for relations must be the first normal form relation must be contain any must not contain any partial dependency. The relation of 2NF, if it has no partial dependency and no non-primitive attribute, that is the attribute which is not part of any candidate key, is dependent on any proper subset of the key, candidate key of the table. Partial dependency. If the proper subset of the candidate key determines non-prime attribute, it is called partial dependency. That is, the attributes are student number, course number, and course fee. These are the table here. So course key will have a prime attribute that does not belong to any one of the candidate keys, like student number and course number. But course number and course key, that course key is dependent on course number, which is a proper subset of candidate key. Non-prime attribute course key is dependent on the proper subset of the candidate key, which is partial dependency, and so the relation is not a 2NF. To convert the above the relation of 2NF, we must split the tables into two, that is student number and course number and course fee, as above, as shown in the figure. Now, note 2NF tries to reduce the redundant data getting stored in memory. For instance, if there is 100 students taking C1 course, we don't need to store its fee as 1000 as all 100 records. Instead, once we can store the second table in the course fee for C1 as 1000. The third normal form. Relation in the third normal form, if there is no transitive dependence for the non-prime attributes as well as it is in the second normal form. Relation in the third normal form, if at least one of the following condition holds in every non-trivial relation dependence, that X is dependent Y. So your X is called the super key and Y is called the prime attributes, for every element of Y is part of some candidate keys. Serial number, serial name, serial, that is student state, student country, student age, as above in the table. Transitive dependence, if A is depending on B and B is depending on C, then two functional dependency are A is depending on C is called a transitive dependency, means that non-prime attributes depends on non-prime attributes, like irregular student depends on another irregular student. In relation student given in the table, functional dependence sense that student number depends on student name and student number, which again depends on student state and student state, and the student state again depends on student country, and student number again depends on student age, and the next candidate key is nothing but the student number. So that is the unique key. So for this relation, student number is depending on student state and student state is depending on student country, and it's true. And so student country is transitive depending on student number. It violates the third normal form. To convert the third normal form, we will decompose relations student number, student name, student phone, student state, and student country and student age as student number, student name, student phone number, student state, and student age, student country, state, and country as shown in the table below. BCNF, they called Boyne's code normal form, is the advanced version of 3NF, a table of BCNF in every functional dependence. X is depending on Y, and X is the super key of the table for BCNF. The table should be third normal form, and every functional dependency left-hand side is a super key, as shown in the table. If the student teacher depends on student subject and depends on teacher subject, and the candidate key are student teacher and student subject. The above relation of 3NF, since there is no transitive dependency, a relation and R is a BCNF if for every non-trivial function dependent X depending on Y, X is a key. The above relation is not in BCNF because the functional depend teacher and subject depending on subject, teacher is a non-key. The relation suffers with anomalies. So, for example, if we try to delete the student Subbu, we have to lose information of R plus our teacher C. So this difficulty is caused by the fact that teacher is determining but not the candidate key. So decomposition of BCNF, the teacher is depending on subject while is BCNF, since teacher is not a candidate key. And if X is depending on Y, while is BCNF, then divides the relation into R1, that is X1, X and Y are attributes, and R2, R and Y. So R is divided into two relations, R1 and R2, where R1 consists attributes of teacher and subject, R2 consists attributes of student and teacher. Here as shown in the figure. All the anomalies which were present in R now removed in above relation. So BCNF decomposing does not always satisfy depending preserving properties. After BCNF decomposing, if dependence is not preserved, then we have to dedicate whether we want to limit BCNF or roll back to 3NF. This process of rollback is called denormalization. So fourth normalization is a level of database normalization where there is no non-trivial multi-value dependency other than candidate key. It builds on the first three normal forms, first three normal forms and Boyne's normal code normal form. It states that in addition of database meeting the requirement of BCNF must not contain more than one multi-valued dependency. Properties are A relation R is in 4NF if and only if the following condition. It should not be in Boyne's co-normal degree. The table should not have multi-value dependency. A table with multi-value dependence violates normalization standard for 4NF because it creates unnecessary redundancy and can contribute to inconsistent data. To bring this up to 4NF, it is necessary to break this information into two tables. When certain values of codes, there are certain values of instruction and textbook, and there exists no relation between instruction and textbook. So it is called multi-value dependency. Codes is depending on instructor, course is depending on textbook, as shown in the figure in the table. So decompose so that these multi-value dependencies is remove the teacher relationship and textbook relationship as shown in the tables below. If the normal form, if it in fourth NF is not contains any joint dependency and joining should be lossless. 5NF is satisfying where all the tables are broken into many tables as possible in order to avoid redundancy. 5NF is also known as project join normal form. So R is decomposed into R1, R2, R3, and R1 join R2, R1 join R3, R2 join R3 should be back to original relation R. They should not have any loss of data in terms of tuples. Lossless joint decomposition. If we decompose the relation R and R1, R2, and we join them again, and we should not have any loss of data, then it is termed as lossless decomposition. R has attributes A, B, C, D, and R1 is A, B, R2 is D, and there is loss of data because it does not have C in R1 nor R2. The relation R is decomposed into two relations. The R1, R2, which is lost, that's R is divided into R1, R2, again joining to get R. So that is shown in the figure, and these are the commands for this. Okay. So what we are seeing, this is the table dividing to this. Again, joining this, we're getting this. So R1 ABC, R2 is BCD, RD this one, that is in the right of this column. Domain key normal form. A domain key normal form keeps a constant that every constant in relation is a logical sequence of the definitions of keys and domains. Sixth normal for a relation is said to be sixth normal form such that relation R should not contain any non-trivial joint dependency. All six normal forms consider temporally dimensions P to the relational model. Key point for relational normal form is key for redundancy. The relation of BCNF and 3NF is also satisfied if all attributes of the relations are prime attributes, and the relation is said to be 3NF. Relation in the relational database is always at least in normal form. So every binary relation is always in BCNF. Relation has only single on candidate keys, then the relation is always 2NF. Sometimes going to BCNF form may not be preserved functional dependency. In the case, go for BCNF only if the lost functional dependence is not required as normalized till 3NF only. There is many more normal forms that exist after BCNF, like 4NF and more. But in real world database management system, it generally not required to go beyond BCNF. So that completes our syllabus. And so coming to this, and that completes, and there are few the revision videos also I'll be loading it. Please consider this. Thanking you.